So for this week, just a heads up, what's due today is your student choice project. Make sure that that's posted on Padlet. And also,
I've been seeing some of them. They're pretty good so far.
Yep, exactly. And of course, quizzes, waves is due and it closes at 11:45. You already know that it's going to close automatically after 11:45. So you don't be logging in at 11:45 because you will definitely close out. All right. So for the week, analog and digital signals, that's what you guys will find out. That's why it's called investigation. You guys will be looking into what are those two words that you may have heard every day. So this is an application of what we talked about waves and its properties. I'll discuss that after a breakout session of what to do with those investigation. And then day 3, continue with that. And then, of course, your discussion post is due that day on Wednesday. And then day 4, the second part of your investigation will be posted, and that's due on Monday. The first part of your investigation is due Friday. And then day 5, you guys will be doing a Career in Science and Technology dress-up day. If you feel like you don't want to be dressing up, then you have to find creative ways on how you can show careers in science and technology, and you're going to be talking about them. So some of you guys might have some Halloween costume that you wear that's like a career in science and tech. Go for it. Otherwise, have some creative ways on how you can demonstrate and showcase careers in science and technology.
For example, if you wanted to be a marine biologist, you could have a little shark.
Yes, exactly. Thanks for that idea, Mrs. Watkins. But that's actually what we are aiming for your STEMologist's Career in Science and Technology Dress-Up Day and Flipgrid. And you know very well, I've posted some people who have demonstrated an energy transformation on Instagram. Of course, if you have that amazing, amazing presentation for your Flipgrid, then of course, I'll post that on Instagram too. All right. And then of course, week 5 next week, that's when your analog and digital signals investigation part 2 due and the Flipgrid due.
Awesome. Okay.
So today we're going to talk about analog and digital signals, their differences. So I'm sure you've seen those two not really equivalent, but 2 different versions, analog and digital signals in terms of the device that you see here, the rotary dial telephone and your smartphone. And that's kind of like a background of what we're going to do. So our questions today, how do we differentiate analog from digital signals? What are some analog and digital gadgets we encounter every day? And what are the advantages of digital signals over analog signals? So that's going to be our info. Nathan, thank you for that comment about analog and digital signals. We're going to find that out later on. Analog binary signal, so either 1 or 0. So that's the digital. So we're going to talk about that today. Yes, Mrs. Watkins?
And I was also thinking, considering the pandemic and stuff, I just remember sometimes when storms happen, you know, having a rotary phone can actually plug into the wall and you get the hard line when your cell phone's not working. And I just remember, I'm like, why does my dad, he doesn't have it connected to the wall all the time, but it's as a part of his emergency kit so that when that happens, if the phones aren't working, you can still have access to the telephone. So sometimes analog might be better than digital, and sometimes digital is better than analog. It depends on the situation.
Yes, and that's what they're going to find out throughout the week in their investigation for analog and digital signal. That being said, while we're watching this video, you guys will think about when and how you encounter analog and digital signal in your everyday life. So be ready to answer the questions after we're done watching, and then we're going to move on today. So this is a background of analog and digital signals. All right, so let us watch. And if you have any questions, just type in the group chat. Oops.
Awesome. Analog and digital signals. There are two different ways of sending information, either by analog or by digital signals. So what's the difference? Well, let's look at the analog signal on screen. We can see that it varies continuously in both amplitude and frequency. And the signal can take one of many different values. Now let's look at a digital signal. So here we see that the signal can only take two values, either a 1 or a 0, which we sometimes call on or off. Digital signals are sent as a series of pulses of either 1s or 0s. Okay, so that's great, but which is better? Well, digital is a much better way of sending information over long distances. Now let's see why. So here is someone talking on a phone. The signal from their voice is analog sound, and it enters the phone and is converted to a digital signal and then sent out via microwaves to a phone mast, which then sends it on to a satellite and then back down to another phone mast and then on to the person receiving the phone call. Let's look at the signal received by that phone. If we look, we can see it has picked up a lot of noise or interference, but it's still really obvious exactly what it should look like, so the phone can easily convert it back perfectly to be the same as the original signal. Now let's look at this using analog. So now the analog signal, the sound, enters the phone and is turned into an analog electrical signal and sent down copper wires. Now, note how it picks up noise and interference, and the amplitude is reduced as it travels until it gets to the other phone. Now let's look at it again. It looks very, very different to the original signal now. It's almost completely impossible to know what this signal should have looked like. And it needs amplifying as well. This amplification is only going to amplify the noise just as much as it does the signal. So noise or interference has really damaged the analog signal. And this is why digital is so much better than analog. Noise or interference is just not a problem for digital, but is a huge one for analog, making digital signals much higher quality. Other benefits of digital are that it can carry much more information. In fact, you can send multiple different signals all at the same time. And digital signals are also easily interpreted by computers.
All right. And that was it. So pretty much analog and digital signals, we encounter that every single day, but we need to differentiate the two. That is your goal today. So we're going to spend a little bit more time today in our breakout session, but in that breakout session, you just don't stay in there and not do anything, but you guys will be answering the questions together with your group mates, okay? So you're gonna be randomly assigned to the group, and the questions you guys will answer are these questions. Now, this is similar to your prompt questions in Google Classroom, so you can write it down, and then later on after our session, you guys will answer it actually in Google Classroom. All right, so first question, what's the difference between analog and digital signal? Just one. 3 examples of analog devices you know. You guys will share that together, share the answers together. Mention 3 examples of digital devices that you know, and which signal do you think is better, analog or digital? And you guys will be explaining your answer. So now that we are all back in here, so just quickly before we wrap things up, because you guys will be investigating about these 2 signals on your own in our investigation for the week, let's just quickly answer. So Connor volunteered to let us know the difference between analog and digital signals. Can you share with us, Connor?
Well, analog, it can go on forever. Also, digital has to go a lot longer than analog has to.
Right?
Because it has to go from your voice to the phone to the cell phone tower, to satellite, to another cell phone tower, to the phone, and to the other person's ear.
Cool. Thank you for sharing. Now let's call someone who would like to share one example of an analog device. Anybody? Click the raise your hand button if you would like to share one example. Yes, Brooke. What's our answer, Brooke? Give us one. Brooke, are you there?
Yeah, I'm there.
Okay, great. One example of analog device.
A wired phone.
A what?
A home phone. An analog phone.
An analog phone. Yes, that's correct. How about two examples of digital device that you know about? I have Mary. Go ahead, Mary.
Not two digital devices is found in a computer.
Yes, that's correct. Anyone else who would like to share? Yes, Tiana.
Is this about
Yeah?
the analog or the digital?
Digital.
Oh, like an Apple Watch?
An Apple Watch. Yes, that's correct. Thank you for sharing. And let's have one advantage. Emmett, would you like to answer number 4? Emmett, are you there? All right, Emmett, can you share with us an advantage of which do you think is better?
Well, probably like digital, because like it doesn't need a medium to go through. It goes through the air. It doesn't need any copper wires or like landlines.
Right. Yeah. Exactly.
Is air a medium?
Is air a medium?
Yeah, I guess sort of.
Right.
Yeah. So analog could also still go through buildings and trees, different things, but
Yes.
it goes through much smoother and it doesn't require a specific medium.
Exactly. And later on, when we talk about electromagnetic waves, they do not need a medium in order for it to be transmitted, which we'll talk about next week. That being said, so this is a summary of the differences between analog and digital signal. Analog continuous, digital non-continuous. Analog never-ending range of values, digital finite range of values, and usually it's ones and zeros. Now, analog have more exact values, digital not as exact as the analog signals. And lastly, it's more difficult to work with analog, and later on you'll find out why some analog media may need to be converted to digital, because digital actually stays longer, can be distributed faster, and easier to work with when we talk about those digital devices that we have.
Mm-hmm.
Okay, so just a summary of what you guys will investigate on. Part 1, you're going to watch these, read these, and sort these. It's kind of like what we're doing in the station labs, but the difference is that on the first part, there are 3 short videos and you answer the questions. Read these, analog and digital signals, connected to our lesson last week, which are waves, and the sort these. There are analog and digital devices, and you guys will classify that one or the other. And then for the part 2, to digitize this one, you're going to research about digitized media using suggested sites. So it's kind of like researching on something and you're going to answer the questions. And it also has to do with why is it that we need to convert some analog media that we had in the past to digitize this? Why is it important to do that? And lastly, for techno, this is going to be kind of like an application. So you're going to look at technology at home with actual pictures that you have, and you're going to answer some questions about what you found at home. Okay? So that's pretty much it today. And overview of our assignments is on the left-hand side of me while I read. That's my thing. Consultation hours is on Thursdays 1 to 2. And I hope that it clears everything up for the week and we'll set ourselves up for success for this week. Ed Puzzle today and discussion post will be in Google Classroom. If you don't have any more questions, you can show your way out. See you next week. Bye.
Bye.
Hi guys, week 4. This is going to be our schedule for the week. We are talking about analog and digital signals. Today, our due is your student project and the quizzes. Tuesday, Wednesday, we're going to work on our analog and digital signals investigation part 1. Wednesday, discussion pose and ed puzzles due. Thursday, the second part of the investigation on analog and digital signals will be out, and it's not due until Monday. Now, the first part of the investigation is due on Friday, and on Friday, you guys will be using Flipgrid to showcase STEMologists or careers in science and technology. So you're going to post that on Flipgrid. If you have other what do you call this creative means on how you can showcase these careers, you are more than welcome to do so. All right, so that's it for the week. Please make sure that we get on our assignments and finish them on time. And we'll see you next week, hopefully. Bye.